In 1999, a satellite phone network that cost over $5 billion to build went bankrupt in less than 9 months. 66 satellites already in orbit, circling the entire planet, were scheduled to be deliberately destroyed, burned up in the atmosphere, because nobody could find a reason to keep paying for them. They were saved at the last possible moment by a single buyer who paid roughly $25 million for a network that had cost over 200 times that much to build, a network that, decades later, is still fully operational and quietly profitable. This is the story of Iridium, and it might be the most expensive, most literal example of bad timing in the entire history of telecommunications. The idea began at Motorola in the 1980s, built around a genuinely ambitious engineering goal. A phone that could call anywhere on Earth, from anywhere on Earth, using a constellation of satellites in low orbit instead of relying on ground-based cellular towers. No dead zones, no difference between a city street and the middle of an ocean. Just a phone that worked literally everywhere on the planet. All the time, a promise no ground-based cellular network could ever fully match, since towers can only ever cover the land they're physically built on. The system needed 66 satellites to make that promise work, positioned in low Earth orbit so calls wouldn't suffer the delay you'd get from a traditional, much higher geostationary satellite. The number 66 wasn't arbitrary at first. The original design called for 77 satellites, matching the atomic number of the element iridium, which is where the company's name came from. Engineers later found they could cover the globe with fewer satellites, but by then, the name had already stuck. An accidental piece of branding built entirely on a design specification that didn't survive to the finished product. Motorola spun the project off into its own company, and by the time of its commercial launch, investors had poured in something in the range of $4.3 to $5 billion. Even before launch, there were warning signs. A market research study conducted by Gallup in 1996 reportedly concluded that Iridium's business model was severely flawed, raising doubts about whether enough customers actually existed for a product this expensive, aimed at a use case most ordinary consumers rarely encountered. The company moved forward anyway, continuing toward launch and eventually taking the company public, betting that the sheer novelty and reach of true global coverage would create its own demand once the network actually existed. Commercial service finally began on November 1, 1998. By May of 1999, just 6 months later, Iridium had signed up only about 10,000 subscribers, a tiny fraction of what the business needed to survive, let alone turn a profit on a multi-billion-dollar satellite network. In August of 1999, the company defaulted on $1.5 billion in debt and filed for Chapter 11 bankruptcy. By March of 2000, with only around 50,000 subscribers ever signed up in total, Iridium shut down commercial service entirely. Motorola's own financial exposure to the collapse came to an estimated $2.2 billion. Here's the part of the story that sounds almost too dramatic to be true. With no buyer in sight, and the ongoing cost of maintaining 66 satellites in orbit weighing on Motorola, the plan became to deliberately deorbit the entire constellation, deorbiting each satellite so it would burn up harmlessly in the atmosphere, permanently ending the Iridium network rather than continuing to pay to maintain it. A multi-billion-dollar engineering achievement, fully operational and orbiting the planet, was genuinely on a countdown toward being turned into nothing more than streaks of light in the upper atmosphere. That's when Dan Colossi entered the story. Colossi was an airline industry veteran, having previously run Pan American World Airways and Canadian Pacific Airlines. With no direct background in satellite telecommunications, he assembled a group of investors and purchased essentially the entire operating Iridium network, including all 66 satellites, for approximately $25 million, against a network that had cost well over $5 billion to build in the first place. The story is detailed in the book Eccentric Orbits by investigative journalist John Bloom. and separately in A Telephone for the World. Written by Smithsonian National Air and Space Museum curator Martin Collins. So what actually killed the original Iridium, if the core technology worked exactly as designed? The answer is almost entirely about timing, and about a competing technology that improved faster than anyone expected. While Iridium spent years designing, funding, building, and launching an entire constellation of satellites, ground-based cellular networks were expanding rapidly and getting cheaper at the same time, covering the exact populated, profitable areas that any phone company actually wants customers in. Building and launching 66 satellites takes years under the best circumstances. Building a new cellular tower, by comparison, can happen in months. That difference in speed meant the competing technology simply had more chances to improve, expand, and drop in price before Iridium's much slower, much more expensive infrastructure ever went live. By the time Iridium's satellites were finally operational, ordinary mobile phones already worked in almost every place people actually lived and worked. Satellite service was left covering the genuinely remote parts of the planet, deserts, oceans, mountain ranges, markets that were real, but far smaller and far less profitable than the mass consumer market Iridium had originally been built to capture. The handset itself didn't help. Iridium phones were notably bulky compared to the cellular phones of the same era, with a thick antenna that made them look closer to a military radio than a consumer device. And they required a direct, unobstructed line of sight to a satellite to function at all, meaning the phone that promised to work absolutely everywhere often struggled to get a signal indoors, in cities with tall buildings or under heavy cloud cover. Precisely the environments most ordinary people spend the overwhelming majority of their time in. A phone engineered for the open ocean, an empty desert turned out to be a frustrating experience in the exact places its earliest customers actually tried to use it. Here's where the story takes its strangest turn. Under its new ownership, Iridium quietly became profitable, initially finding steady demand from government, military, maritime, and aviation clients who genuinely needed guaranteed global coverage regardless of cost. By 2008, the company was healthy enough to merge with a publicly traded investment vehicle in a deal worth roughly $500 million. Under CEO Matt Desch, who has continued running the company through its second act. Decades later, Iridium phones have shown up in television shows like the series 24. Been carried by round-the-world solo sailors relying on them for emergency contact across tens of thousands of nautical miles, and remain a functioning, profitable satellite network today, the exact infrastructure that was almost deliberately burned up in the atmosphere for the crime of arriving a few years too early. Aimed at the wrong customer, Iridium didn't fail because satellite phones were a bad idea. It failed because a competing technology, ordinary cellular networks, happened to be improving on a faster curve at exactly the moment Iridium needed the market to still be wide open. The engineering promise, a phone that works absolutely everywhere on Earth, remains just as true today as it was in 1998. It simply turned out that almost nobody needed that promise as badly, or was willing to pay as much for it, as the multi-billion-dollar bet assumed they would, and it took a bankruptcy, a near-deorbit, and one airline executive with no satellite experience at all to find the much smaller market that actually did. End of line, technology that almost changed everything. Subscribe and check out the rest of the channel. New stories of technology that almost changed everything. Going up every day.